Okay, welcome. This is a tactical technician video from Diagnation, and today we're going to talk about microclamps, scopes, sensors, and pin fitment. We're basically going to look at a sensor. It's going to be a cam sensor. This car has two of them. They are Hall effect / magnetoresistor 3-wire sensors. Cam sensor in this case, it gets its power from power distribution from a PGI main relay. At the top, you can see it does not get its reference voltage from the PCM. It is fed full voltage from the relay. Its signal goes to the PCM, and it is grounded. The sensor is grounded to the engine. So basically, we have a 3-pin sensor, and we're going to look at the sensor in a kind of a unique way that may add to our diagnostic advantage. We're going to use a micro clamp clamped around the power feed to the cam sensor. And that will be on channel A of the scope. Channel B of the scope is going to be at the power feed, looking at the voltage going into the sensor. Channel C green is the signal from the cam sensor to the PCM, and our D channel, our black channel, is the ground of the cam sensor. I'm going to create situations where I'm going to create a very authentic pin fitment issue, one pin at a time. As you could look at the schematic, take a snapshot of it because it'll help you when we're looking at the scope. We got 3 pins at the connector. We got a connector on the cam sensor, and you can see that we call that pin fitment. If we have a micro-fretted terminal or some where the terminals got hot or something and there's resistance there, it'll definitely affect our signal. And adding the micro clamp may give us more of a diagnostic advantage, in addition to looking at the sensor on a voltage level. So we're going to have voltage and current flowing through this sensor. Now, I've tested most of these sensors, and they draw about between 9 to 10 milliamps of this type of sensor. So anyway, I will go to the scope, and we'll take a look at we'll start out by looking at a normal signal without any problems. We're going to see 4 signals on the scope, and I'll explain each of them. We'll kind of go through them and see what they are. And here we go. Let's get us set up here so we can see. Okay. I'll start the car, and then we'll stop the car and kind of analyze what normal is. Okay. Yeah, we got a lot of blue. That blue will go away. We're going to kind of filter that. That's actually our current. So let's stop the scope, and we'll stop the car and we'll analyze. All right. There we go. Okay. As you can see, the blue channel is our current flowing into our sensor, as you kind of reference your schematic. And that's going to be, as I said, about, let's see what that is. Okay. I'm getting about 7.7 milliamps flowing into the sensor. So that's, they don't draw a lot, but they do draw something. Our red channel is our power feed at the sensor, and that's strong. That's charging voltage about 13.45. Green is our signal. Let's kind of open that up. That is our cam, our intake cam signal, and I'll stretch that a bit so you got a little more resolution. And that's that is the cam signal, as you can see. In green, and our 4th signal is the ground of the sensor, and I'll kind of take a look at that. That's right here, and that is I'm getting about 6.1 millivolts. So that's a good ground. And so what I'm going to do is I'm going to do 3 different situations from now. I'm going to cause a pin fitment, a very intermittent pin fitment issue at each of the pins one at a time. At the power feed, at the signal feed, and at the ground feed, the ground pin of the sensor. So 3 different situations. We're going to see the effect of voltage, current, in particular current, because we're going to I think the micro clamp can tell us a lot in addition to just looking at voltage signals at a sensor. So anyway, I'll start the car. Let me set it up, and we will look at a pin fitment issue on the power side first. If we had a very intermittent issue at the power terminal at the cam sensor. Our scope leads are hooked about 3 or 4 inches away from the sensor. So we're gonna just as you look at your schematic, take a look at where the scope leads are. The pin fitment issue will be pretty much at the sensor or at the connector. So here we go. Okay, let's start the scope. Okay, now we're analyzing. Now we're going good, but take a look at, well, we'll stop it now. Okay. You start to see something, we'll stop the scope and analyze it. We got a very intermittent pin fitment issue. That's the voltage feed to the cam sensor. Okay, now we stop it and we'll roll it back. And I'll stop the car. Okay, as we can see, we once we open at that pin, at that power feed pin at the sensor, current will stop flowing. So we can see in blue, and we stop. We lose our signal. Obviously, there's a right there. We lose our cam signal, and we lose because we've lost current because we have an open at the feed right at the connector at the pin on the cam sensor. Our voltage is staying strong because our test point is a little more upstream from that. So you got to think about the test point of the scope. The scope lead is a couple inches away from the sensor. So we're strong there at the as far as our voltage feed. We've lost current, so we know where we're open circuited. Our ground is still good, so we know that our ground was maintained, and we lost our signal, and we stopped flowing current. So we would pretty much, if we were on a diagnostic situation, we would infer that we got an open somewhere, possibly in the connector, in the pin, in the sensor itself, and the inner workings of the sensor. It's basically a transistor and a Hall effect and a Schmidt trigger, got some electronics in there. So anyway, I will create the second scenario is going to be a pin fitment issue at the signal pin, only at the cam sensor connector. Start the car. Okay. Let's get the scope back to normal range and we'll start it running. Okay, we're going across the screen now. Take a look. Now we got to see what something happened here. All right. Got an intermittent at the sensor. We know this would cause a performance issue, probably a check engine light. Stop the scope and let's analyze. Okay, looks like we lost our signal intermittently because we had a pin fitment issue at the signal pin on the sensor. But take a look now that we did maintain current. Our current was still maintained. But we lost the signal going from the sensor to the PCM. Our voltage was strong. We still maintained a good power feed to the sensor, and we still maintained a ground. But nonetheless, our current sort of tells us something that that we have current flowing into and out of the sensor, but since our pin fitment issue was at the signal pin, that it lost the signal going to the PCM. So basically a little different than the first scenario where we were compromised at the power feed pin on the sensor. Now this will be the final one. I'm going to tell you, look, what a pin fitment issue on the ground pin would look like. Start the scope. Okay, we're rolling across now. Take a look at your signal. We're going to have an issue with the ground pin at the cam sensor. Okay, let's take a look. We'll stop the scope. Okay, now. Okay, oops, my bad there, sorry. Okay, now we got being that we have a pin fitment issue at the ground pin of the sensor. Okay, our ground is not lifted, and there's a reason for that. It's because our test point, we have our scope lead about 3 inches away from the sensor, and our pin fitment issue is at the sensor. So basically our signal gets lifted. Take a look at green, and you could see that our signal, since our ground is open at the sensor, our signal goes high. It goes full voltage. Look at that. Our signal is about 11. That's about almost operating voltage with some variables as far as charging. Okay, there's our charging voltage, which is still strong. Our current stopped flowing, again, because the ground circuit is that closing loop of that circuit. And when that opened up, we stopped flowing current. So we can see right here the money shot of current not flowing through the sensor, the signal being lifted. As you can see right here, we're lifted up to like high voltage or system voltage, and our system voltage, our feed remains strong. So this just goes to show the advantage of a micro clamp. I think it's a powerful tool. It's underutilized. Unfortunately, it's so expensive. This one that I'm using is a pricey tool. I got it used on eBay. I wish maybe the tool manufacturers start to make them. They're great on networks and in so many different ways, but this is just a way we can learn more about if we had an intermittent crank signal, cam signal, tranny speed signal, any speed signal that deals in very low amperage, but nonetheless it does pull a little bit of amperage. And as we can see, I'll just close this off now. Our amperage flowing through the sensor, we're going to say, okay, we're about 6.2 millivolts to milliamp conversion. So about almost 7 to 8 milliamps flowing into that sensor. But nonetheless, thanks for watching, and start in, if you can, maybe dabble with the micro clamps. I know they're pricey if you can try to get a used one, but I think they're pretty powerful tools. All right, thanks a lot for watching.